Hi, welcome to Building Windows 8 Apps using HTML5, CSS3, and JavaScript. My name is Brett Statham. I'm a Microsoft Developer Evangelist, and you can find me on the web at brettstatham.com, via Twitter at Brett Statham, or via email at brett.statham@microsoft.com. I'll also mention that you can download a copy of the slides and demos in this video using the link at the bottom of the screen. So in today's video, I want to cover three basic topics. First, I'd like to start out with just an introduction to the Windows 8 architecture. And we'll come back and see how to create HTML5, CSS3, and JavaScript apps on top of that architecture. And then finally wrap up taking a look at some of the different HTML5 gaming frameworks that are available. So let's start by taking a look at the Windows 8 architecture. As we look at the architecture at the bottom, we have the Windows kernel. And on top of that, we build our applications. Now, back in the day, if you were going to create a Windows app, we would now call that a desktop app. And there were a couple of different ways that you could create them. You might have used something like C and C++, or maybe VB6 against the Win32 and COM APIs. Or over the past decade, most Microsoft developers have been using .NET and languages like C# or VB.NET, or maybe even running their applications inside Silverlight via the browser. Another popular way to create applications that ran on Windows was browser-based apps. For example, going out and using HTML and JavaScript to create an application that ran in the browser. Bing Maps, Office 365, those are great examples of browser-based applications that we've been using for years now. But with Windows 8, we wanted the ability to create Windows applications that ran not just on Intel-compatible devices, as we have in the past, but also on a whole new family of consumer-based devices running on the ARM processor. And for that, we needed a new runtime. We also wanted to be able to take better advantages of technologies like touch. So to facilitate that, Microsoft created a new runtime and a new class of applications for that runtime called Windows Store Apps. And the runtime that they run on is called the Windows Runtime API, or just WinRT for short. And WinRT gives you the basic things that you'd expect from a runtime API: communication with the network, drawing on the screen and doing graphics and media, printing out to devices, etc. Also, an application model that helps maintain your application through its lifecycle. Now, to write applications against this Windows Runtime API, Microsoft created a layer of language projections, and those language projections give you language-compatible syntax for direct access to the underlying Windows Runtime API. And that means that I can now natively access the Windows Runtime API directly from C# or VB.NET, and maybe using XAML as my user interface markup. You can also access the Windows Runtime API through C and C++. Or, and here's what's really special for this video, is that you have the ability to use HTML5 and CSS3 as your markup and JavaScript as your code behind, with language projections that allow you to natively access the Windows Runtime APIs directly from JavaScript. That means that you can use your web platform skills to create Windows Store apps that can be bundled up, sold in the store, and installed directly on consumer devices. Notice this is significantly different than HTML5 JavaScript apps being run inside the browser. So we'll focus in on that a little bit more as we go through this video and show you how to do just that. The extent that you can access this architecture depends on the type of device you're running on. Windows 8 Windows Store apps, however, are available on all Windows 8 devices. They run on Intel-compatible x86 and x64 devices, as well as ARM-based tablets. The desktop applications, however, are only available on Intel-compatible computers. Now, to differentiate between those, there's two different versions of the operating system. Windows 8 runs on Intel-compatible devices, but on a Windows 8 OS, you can run any kind of app, Windows Store apps as well as desktop apps. Windows RT is run on ARM-based tablets, and it only runs Windows Store and, of course, browser-based apps. I should also mention, though, that with Windows RT, you do get an Office version that's compatible with ARM, as well as two versions of Internet Explorer 10, both a Windows Store version of IE10 as well as a desktop version of IE10. The value of the Windows Store apps then really starts to shine here. First of all, they run on all devices. Both ARM tablets as well as Intel-compatible laptops can run Windows Store applications. And the apps that you create for that runtime can be sold in the Windows Store, hence the name. That means that as a developer, you have the broadest availability of your application across devices. Applications that run against the Windows Runtime API, you get to use contracts like search and share, printing out to devices, having access to the file system, or being accessed as a file store, being able to play out to DNLA network devices, etc. They also get view states. They can run full screen, or they can run in what's either called filled or snapped views. And we'll take a look at that as we design our prototype application coming up. They also have a great application lifecycle. Your application is running when it's on the screen, it's suspended when the user moves away, or it's been terminated maybe because the user powered off the device or resources were required and the app was terminated. There's a ton of other great things that's fully documented that Windows Store apps have access to. To create Windows Store applications, then, it's important that you first know that you'd be running on Windows 8. You can't build from Windows 8 without being on Windows 8. But then you'll also need some tools. You can go to dev.windows.com. From there, you can download a free copy of Visual Studio 2012 Express for Windows 8. There's also a link there to an eval copy of Windows 8. Tons of online documentation, Windows Live and advertising SDKs, a slew of sample apps, etc. Now, of course, if you're already a Windows developer and you have a full version of Visual Studio 2012, you can use that. You don't have to use the Express Edition. There's also a great design tool, as well as a ton of great design guidance. You can go to design.windows.com for tons of documentation and guidance on building good-looking Windows 8 applications. As a design tool, though, we get Blend for Visual Studio, and that's installed for free with both the Express and full versions of Visual Studio 2012. It uses the exact same project structure as Visual Studio, but provides a more designer-oriented user experience. It's great for doing HTML5 and CSS development with interactive mode, and supports creating in a visual way the layout for your view states, animations, and a bunch of other great stuff. And then finally, both Visual Studio and Blend support the Windows 8 simulator. Now, I already mentioned that to do Windows 8 development, you have to be running on Windows 8. So the Windows 8 simulator is not an emulator. It doesn't let you emulate Windows 8 on, for example, Windows 7. But it does allow you to simulate certain things that your actual hardware platform might not support. For example, your actual laptop may not have a GPS built in, it may not have a touch screen, or it might not be able to support certain screen resolutions or orientations. And the simulator can help simulate those for you. All right, well, hopefully that gives you a good overview of the Windows 8 architecture, as well as the tools that you'll need to develop applications for Windows 8. So let's take a look at doing just that, how to create HTML5, CSS3, and JavaScript apps on top of Windows 8. Remember I mentioned that those Windows Runtime APIs are accessible to you directly from the languages that you use through these language projections. So out of the box, we ship with language projections for C++, C# and VB.NET, and then for this video, of course, JavaScript. Inside JavaScript, the way that you'll access the Windows Runtime APIs is through the Windows namespace, and it's in there that you'll gain access directly to the Windows Runtime and things like the application model, data services, the devices like the GPS, graphics, etc. Now, those are low-level APIs, and so to make your coding against that simpler, Microsoft created a JavaScript wrapper around the Windows namespace called the Windows Runtime Library for JavaScript, or just WindJS. So you access it through this WindJS object, and it does a number of things for you. It includes a bunch of controls, like those that C# and XAML developers are used to having, list boxes and rating controls, etc. It provides simple access to the app container and the application lifetime events. It has CSS media query support for the different view states, simplifies the ability to create namespaces in your own classes, dealing with async and promises, the built-in themes for dark and light, etc. Lots of cool stuff built into WinJS. Just remember, you don't have to use that. And I should mention that you can also load other libraries. And you like jQuery? Yes, you can load jQuery in and use it in your Windows 8 applications. So where does your HTML5 app run? Well, remember that a user is going to purchase your application, or at least download it from the Windows Store. So that application is going to get downloaded to a system folder, and it's in that folder then that your application source will exist, the CSS and JS and HTML files, etc. When your user launches your application by clicking on its live tile, an app container is created in memory, and that app container is responsible for managing the lifetime of your application. Now, because JavaScript doesn't compile down to an executable, we needed an exe process to host your application. So Windows includes this wwa host.exe for Windows Web Application, and it's that process that actually hosts the Chakra JavaScript engine and Trident HTML5 CSS engines. Now, those are the same JavaScript and rendering engines that IE10 uses, but it's important to note, if you look at that diagram, there is no IE10. You're not running in the browser. You're running as a process on the operating system. So that's pretty cool. So we then pull in your JavaScript and process it. The Trident engine renders it and produces the output onto the device. So it's key to see that your Windows 8 apps don't run in the browser. Now, you can have HTML5 browser-based apps, but that's not what we're talking about here. We're talking about Windows 8's Windows Store apps that are purchased and delivered to the user through the store. Now, these apps are similar to running in a browser in that the same JavaScript and HTML5 rendering engines are used, but they're not similar in the way that some of the DOM API methods are going to be different. For example, there's no window.alert. We have an alternative to that called the message dialog, which is in the Windows namespace. There's also specific CSS media queries for the Windows 8 snapped, filled, and full view states. Also, for security differences, Windows 8 JavaScript apps can, in fact, make cross-domain XML HTTP requests and cross-domain resource requests. And we'll talk a little bit about contexts coming up here. But there's a ton of documentation about the differences, and if you grab the slides, again, the URL is down at the bottom of the screen, you can follow the links to read up about all the changes. Now, I mentioned that app container. That's the sandbox that your application runs in, and it provides managed access to system resources through contracts. It also provides isolated storage that your application can use to store its own data. And a key part of the app container is this process lifetime. It notifies your application when it's being activated, suspended, or terminated. Now, the code that runs inside that app container also has some additional security implications. And basically, we control that through running code either in what's called the local context or in the web context. And it depends on what it is you want to do as to which context you want to make sure that you run your code in. So code that runs in the local context can access the Windows Runtime API. It can retrieve cross-domain media, and as I mentioned, cross-domain XML HTTP requests, but it cannot load remote scripts off of a remote URL into the application. And that's there for security reasons. Once the application has gone through the certification process and Microsoft has sort of put their stamp of approval and said, yes, this app is safe, we don't want to allow remote scripts to be able to come onto the device and directly access the device itself. So that code that's running in the local context, meaning locally on the device or with access to the local device, does not have the privilege to load remote scripts. Well, there's certainly going to be scenarios where you want to run remote scripts, for example, the various mapping APIs, etc. So in that case, we provide a separate context called the web context. And the difference there is that the code running in the web context can, in fact, download remote scripts and execute them, but with the caveat that it cannot access the local system directly using the WinRT API. So, two separate security boundaries. We do provide a cross-boundary communication mechanism, though, using HTML5's own built-in iframe post-message API. So basically, you create a page that runs in the local context. Inside there, you create an iframe, and then you load code into the iframe that's running in the web context, and then leverage the iframe post-message API to communicate back and forth between them. So how do I tell a resource that I'm loading whether or not it should be in local or web context? And it's the URIs that you use that indicate that. So first of all, local context is used for the first page that's loaded into your application. That has to run in the local context. Anything else that you load using a relative URI is loaded into the local context, or we have a special URI scheme of ms-appx://, and that indicates that we want to load that local resource into the local context. Anything that you load using HTTP or HTTPS, however, is required to run in the web context. And then you can also specify a local resource to be loaded into the web context using the ms-appx-web : scheme. And notice the -web in that URI scheme there. And that makes sure that that code is loaded into web context security mode. To better understand the local and web contexts, let's take a look at how we'll be using them in the demo app we're about to build. Remember, when your app is installed from the store, it exists in a folder on the device itself. Now, the app may also want to access other resources. For example, it may want to be able to communicate with the Windows runtime. In our demo, we'll want to access the GPS. It might want to access resources on the web, like images or videos, and it might want to access scripts that are hosted on web servers. The first page that's loaded into your application is run in the local context. In addition, anything that you load using the ms-appx or just a relative URI is pulled into the local context. When code is running in the local context, it does have access to the Windows runtime. So our local context code is going to be what we'll use to access the GPS itself. Local context code can also do cross-domain XML HTTP requests, or via HTTP just download resources like videos and images. It doesn't have the privilege, however, to access scripts hosted out on web servers. In our case, we want to use the Bing Maps control. Now, that's a JavaScript control that's hosted up on Microsoft's servers. So what we'll do is create a new file, this map.html, and have it be what's responsible for downloading the Microsoft Bing Maps control and displaying it. To do that, we'll create an iframe back in our local context page, and then we'll use the ms-appx URI scheme to load that HTML page into an iframe, and then it has access to the remote scripts and can display the Bing Maps control for us. The code running in that web context can, of course, also access remote web resources, like images and videos, and do so over XML HTTP requests or HTTP itself. So now we have a problem, though. The code running in the local context gets the location from the GPS, but we want the code running in the web context to show it on the map control. So we need a way of communicating between the contexts. And we're going to use HTML5's own iframe post message API to basically build up a payload that we can ship back and forth between the local and web contexts. All right. Well, I promise we're getting close. Let's take a look at the actual prototype of the app we're going to build in the demo. So first of all, this demo is taken from the Programming Windows 8 Apps with HTML, CSS, and JavaScript book by Craig Brockschmidt. That's a free ebook that you can download using the link on the screen. Now, the basic app is called Here I Am, sort of a little play on words there. And there's a few things that this app is going to help us do. First of all, it's going to help us get the location from the geolocation sensors. And that's using the whole web context stuff we were just talking about. We also are going to use the camera capture UI to grab a photo from the camera device. And then once we have that location and photo, we're going to share them out using the share charm that's built into Windows 8. Now, this is what the app would look like when it's running in landscape mode full screen. It's possible, however, for the user to drag that down to the side and run it in what's called filled view. And in that case, we're going to use actually exactly the same CSS for both full landscape and filled view. But our layout's going to be based on grids. And so the grid columns are just going to basically narrow themselves down for the location and photo areas. So exact same CSS. We don't need to change anything in our app for full versus filled. However, it's also possible for the user to drag that over to the vertical column on the side into what we call snap view. And in that case, we want the orientation of the photo and location to go from horizontally positioned next to each other to vertically stacked one on top of the other. And that's just going to make better use of the space. Of course, also, if the user were to be running at full screen but in portrait mode, we want to run a very similar layout to the snap view, but maybe taking a little bit better advantage of the space that's available on the full screen device. So with that said, let's actually get started and see how to go about building an HTML5, CSS3, and JavaScript app in Windows 8. All right, so I'm at my Windows 8 start screen. Let's go ahead and launch Visual Studio 2012. And inside there, I'm going to click on File, New, Project, and make sure I'm under JavaScript, Windows Store. There's a number of templates available, but I'm just going to use the blank app. I'm going to call my project Here I Am, and I'm not going to add source control, but notice I could. Go ahead and say OK. And Visual Studio creates the project structure for me. Let me close this up and walk through the Solution Explorer over here and see what we got. So under References, I see that I've referenced this Windows library for JavaScript 1.0. That's that WindJS library, and we'll talk a little more about that in a second. There's a CSS folder that has the CSS markup for the default page. There's an images folder that has just a bunch of the built-in logos for the live tiles and splash screen and all that kind of stuff. And they're all basically just a transparent file. That's what that green area is, with a white box and a white X in it. So you definitely want to look to putting something more useful or something more attractive in there than the default ones. Right? There's also a JS folder that has the default.js, which implements the script for this default.html. There's the default page itself, a certificate that we'll use to sign our application with when we publish it, and this package.appx manifest. And if I open that guy up, it's basically just a bunch of metadata that manages how the application is shown in Windows, as well as in the store, as well as what are the various permissions that the application requires. And we'll be back in this file later as well. So let's look at default.html. Up here at the top, I see, first of all, the references off to the WindJS library. And these URIs might look a little bit funky with the double forward slashes. That's actually per the spec. And just without the scheme, it just means use whatever the default scheme is. And in the case of a Windows 8 application, that's going to be that ms-appx URI scheme that we mentioned that's used for loading code into the local context. All right. Without that being specified, though, it's assumed. You can also then use a root-based URI or the name of a package. And in this case, the Microsoft.WindJS.1.0 package name refers off to this Windows library for JavaScript, and then infers that there should be a CSS and JS subfolder under there. You notice I can't actually expand it and see the CSS and JS folders. And then the CSS contains the themes for either the dark or light UIs. And by default, we use a dark theme, and that means that we have a dark screen with light elements. The light theme goes the other way, where we have a light screen with darker elements on it. But you can change if you want to use one or the other. And then under the JS folder is just the base WinJS functionality, as well as the UI.js, which implements all of the controls. We'll actually see some of those coming up here in a second as well. The other references that we see inside default.html are off to its own default.css file, and that has just the CSS selectors and attributes for the elements on the default page. And you'll notice that there's an empty body selector, but then there's also some CSS media queries for the full screen landscape and portrait views, as well as filled and snapped. And so we'll be using those coming up here shortly. And then the default.js is where all the base functionality of the default page is actually implemented. Now, I don't really want to talk about that code, so I'm going to go ahead and just select it all and comment it out. And we'll come back and sort of build that back up by hand here in just a second. The only other thing on default.html then is this paragraph tag that simply says content goes here. So let's go ahead and run this. I'm going to go up to my debug menu, and I can start debugging, or just right from the toolbar, I have this debug green arrow button, and I can debug on the local machine, a remote machine. For example, if I have an ARM tablet that I want to try debugging on, or inside that Windows simulator that I mentioned earlier. But I'm just going to debug it on the local machine, so I'll go ahead and click on that, and it'll actually run. We see that logo or splash screen I mentioned earlier, and then notice that the application takes over the entire display. And in the top left-hand corner, I can see that content goes here, text that was inside that single paragraph tag. All right, so it's actually running. Now remember that we have some different view states. Right now it's running full screen landscape mode. My user could come to the top of the screen though and grab the actual app itself and drag it either to the right or to the left and put it into either what we call snap view or into fill view. Right now I'm going to leave it in snap view. I'm going to come back over to this filled view area and actually pull Visual Studio right back up into it. And this is actually really cool. While your application is running, and mine didn't show up here by default, let me go open it up. There's a really cool window called the DOM Explorer. So let me load that. And you'll notice that as I hover over elements inside the DOM Explorer, it'll actually highlight those elements for me over in the application view. And that's a great way to sort of just figure out where the elements are and what kind they are, how big they are, etc. So that's really cool. I also down here have this really handy JavaScript console, and I can use this to sort of interactively work with the JavaScript engine and the DOM itself. So remember I mentioned the Windows Runtime API is accessed through this Windows namespace. I can just type that in and actually go in and inspect that and see all the different types and things like that that I can use from within there, working with HTML data or JSON parsing, talking to the geolocation device, etc. So that's sort of just a handy way to inspect that. And then I said sort of the easier way to work with the Windows namespace is through that WindJS object. So again, I could drill into there, and I said that it's through that we deal with the application, dealing with controls and maybe even data binding, setting promises down here, navigation, a whole bunch of other cool stuff. Right? So let's clear that out. Now I can actually interact with the DOM as well. So I'm going to go ahead and new up a button here. Sorry. And I'll just create an element for it. And I can actually inspect that button just by typing it in. I see the HTML syntax for it. There it is. Let's actually set some text on it. Since it's a button, I'll ask the user to click it. And again, I can inspect it. Pretty cool. And that, actually, let's put a click event handler on there. Now, sort of the hello world example in JavaScript might be to use like a window.alert or something, but I actually mentioned that in Windows 8 apps we don't have window.alert. We do, however, have this thing called a message dialog, and that's off in the windows.ui.popups namespace. It's called message dialog. And I'll just say, hey, you clicked me. That'll be the message that we pop up. Now, this object exists, but it doesn't actually appear until I show it. So I'm going to tell that dialog to show itself asynchronously. I always type that wrong, just to make sure I get it right. Looks good. Now, with an async, it's a common pattern that you'll run into in Windows 8. And basically, anything that has even the perception of having a delay is going to be implemented asynchronously. And that means that I could actually wait for the result to come back from my message dialog. And that might be information maybe about the button that the user clicked on. Well, in my case, I didn't add additional buttons to my dialog. I'm just letting the default close button appear. And I don't really care about the results. So I'm just going to ignore that and move on with life. And it will press enter on that. Again, if I inspect it, I don't actually see the function, but it is there. So really the only thing that remains is to actually add it into the app. So I'm going to go to my document body and append a child of that button. And you'll notice that now over in the application view, as well as in the DOM Explorer, I see that new button has actually appeared inside the body. And in fact, it should be functional. And if I click on it, there's that message dialog appearing, basically saying, you clicked me. So that's pretty cool. Now that was just a regular HTML5 element. I mentioned that WindJS actually includes this concept of controls. So let's say I wanted to have like a rating control, like the number of stars that go across, and you can pick, 3 stars or 5 stars to sort of implement how much you like or dislike, the thing that you're rating. So I'm going to go in, and the way that controls are implemented here in JavaScript is that we're going to start with just a regular HTML element, like a div, and then we'll tell the JavaScript class to sort of take over that div and change its look and feel and behavior here. So the first thing I need to do is to just new up a div here. So I'm going to go to document.element, or sorry, create element, and we'll new up a div. And if I look at my rating control, I see it's just a div, right? I could even set some inner text on that, right? Rating dot inner text. Gee, I wish I were a rating control. Something like that. And if I actually go look at rating again, I can see that inner text, right? Now at this point, it's really just a div. The way that I make this be a control is I have to somehow indicate on this element what type of control it needs to be, right? And so on this, I'm going to add an attribute. And you could really set any attribute here, but I specifically need to set the one that WindJS is looking for to indicate what kind of a Windows 8 control this needs to be. So we're going to leverage HTML5's data star attributes. Now these are per spec extensions to HTML5 that allow you to sort of add your own private data or your own extensions onto the HTML5 specification there. And so the extension we're going to use here is win-control. And so the Windows Runtime or the WindJS library is going to go look for that specific attribute and then inspect its value to find out what type of control we want it to be. And so we're going to have it be one of those WindJS UI rating controls. All right, so we'll set that up and let's reinspect our div here. And so we can see that attribute has been set on it. Pretty cool. Well, let's try adding it to the body again. So we'll go to document.body, append child, and we'll toss in that rating control. And gee, I wish I were a rating control, but it's not. It's not those cool stars that I can click on. And that's because WinJS right now just sees this div. Even with the attribute on there, it doesn't know that it's supposed to make it a control until I tell it to actually go process that control and inspect the attributes and then assign the appropriate control class to it. So the way I do that is I go to the WindJS library. In the UI namespace, there's or the UI object, there's a function called process. And I tell it the control I want it to process, and watch as soon as I press enter. Watch over there in the, well, first of all, you can see in the DOM Explorer what happens, as well as up here in the application view. But I'll press enter, and boom, I've got my stars. And notice that my DOM Explorer, the markup for that div has changed significantly, right? So that's sort of how those controls get implemented. We wire them up, we put the right attributes on them, and then at runtime, we have to make sure that those controls get processed. All right. So now I think it's probably safe to assume that you're not going to be adding controls to your element through the JavaScript or to your app through the JavaScript console at runtime. So let's go back and see how we would do this a little more appropriately. So first of all, from Visual Studio, I'm going to stop my debugger and just let it take back over the full screen there. Now, let's go ahead and manually add in a div there. There's that data dash set of attributes, and notice that there's a few other ones that Windows 8 adds in. So we saw data dash win control. You can also set properties on your control with data win options. There's bind and bind source for doing data binding, and data dash win dash res for accessing resources there. But I'm going to do a data win control, and notice IntelliSense then shows up the different types of controls that you can have there. But there's app bars and date pickers, flip views, list views, etc. I'm going to use that rating control. And we'll stick that same G, I wish I were a rating control text into that div. All right. Now, so this doesn't actually get turned into a control, remember, until this control gets processed. And that's really what the boilerplate code that was in that default.js was doing for us. So just ignore the code down here for now. And let's just think about the JS, take a little sidetrack here. Just think about what this page does and how it gets used. So first of all, this is where I could just go in and start declaring, and initializing variables, etc. The problem that I have with this is just declaring variables right there at the top of the file is that I start to clutter up the global namespace. I might have multiple pages, and I might want to have a variable X that means something different to each page. And doing it this way, it's up in the global namespace, and it's just cluttering that up for me. So to give this page its own scope, I'm going to go ahead and create an anonymous function. And I'll put everything that I want to run on the page inside that function. But I need it to run automatically. So I'm going to make this a self-executing anonymous function just by wrapping it up in parens and then passing in a list of empty arguments. All right, so now I've got sort of scoped code here. And this is where I could go in and start to declare, variables, etc. Well, remember that WindJS object I mentioned helps us access the application. And we actually use that a fair amount, especially as we want to run code when we're being activated or suspended or that kind of stuff. So I want to have a variable that I can use to reference that easily. So I'll just make this app variable. And hopefully if you're a JS developer right now, you're kind of cringing because I didn't declare the variable with the var keyword in front of it. Well, the problem is JavaScript is tolerant enough to actually let me do that. But you well know that that could actually cause semantical or logic errors down the road if you accidentally misspell a variable name or something like that. So in JavaScript, we can add in this use strict string literal, and JavaScript parsers that know what to do with that see that string and go, oh, okay, I'm supposed to enforce variable declaration. JavaScript engines that don't know what that means just ignore it and go, oh, string literal, woohoo, and move on. But if I actually try to run right now, you'll notice that it breaks and says that I've got a variable undefined in strict mode out there on line 5, column 3. So let's break out of that. And there it is. And basically, I need to put the var keyword in. So it's going to make me do that. And that's good. That's a good error. I like that error. Cool. So now with that app object, there's a number of things that we can do, but notice that I can respond to the on activated and on checkpoint, on error handlers, and all that kind of stuff, right? On activated is a place that I can write code that executes when the app is launched, basically. So I'm going to add in a function here. It's going to take in a collection of arguments. And I mentioned all these other app lifecycle events that occur. None of them actually happen until the app is started. So down here at the very bottom, I'll start the app. Now, there's actually some things that I want to do up in app.onActivated. But to better understand them, I'm going to go ahead and place a breakpoint here on the closing curly brace of the method. And let's go ahead and debug it. You'll notice it stopped. Let me flip back over to the actual app, which right now is just sitting on the splash screen, and I'll pull it to the side so we can see it. Let's take a little closer look at this args argument. So if I investigate that, I see it's an object, but the thing I'm specifically interested in is this set promise function down here. And if I scroll down a little bit more, I can actually read the description of it. And it says that this is used to inform the application object that asynchronous work is being performed and that this event handler should not be considered complete until the promise completes. Cool. So I can basically use args.setPromise as a way of sort of telling it inside here some code that I'd like it to run and make sure that it finishes that code before the rest of the app continues here. So the code I want to run is to go and process all of those controls. Remember, the data-win control attributes didn't actually take place until we processed the controls. So I'm going to use that WindJS.ui. Remember that process function, but notice there's another one right below that that does process all. And it'll just walk the whole HTML tree and find any controls that have a data-win-control attribute and wire them up to their appropriate WindJS classes. So I'm going to go ahead and call that. Now, if I actually look at that function, come on, type it right. Remember, the args.setPromise method needed a promise as its argument. And if I scroll down here and look at my process all function, I see that it returns a WindJS promise. Very cool. All right, so that's all wired up. Let's go ahead and stop our debugger and remove our breakpoint here and rerun the app. And when we do, we should see our rating control appear, and that's because we let the process occur during the app activation. All right, so to close this, I'm just going to actually move my hand back up to the top of the screen, cursor, sorry, back up to the top of the screen until it turns into a hand, and then I can click on it and drag it down and just sort of throw it away. And back over in Visual Studio, you'll notice that it actually waits for the app to actually terminate for a few seconds. Eventually, the app does get terminated, and then Visual Studio exits debug mode, and there we see that just happened. You could also just click on the Stop Debugging button if you don't want to wait for that to happen. All right. So at this point, we've basically re-implemented the same intent as the boilerplate code that I'd commented out earlier. There were a few things that were different here. There was this optimized binding references, and that just helps remove any memory leaks that might occur when data binding is used with WindJS. There's also this activation reference, which just helps us track the kind of launch that occurred that caused the application to run in the first place. But the whole if-else branch here just has commented out code, so we don't actually act on it. And there's that set promise on process all. There was also a commented out version of on checkpoint that you could look at to understand how you might want to implement code when your app is being suspended. But otherwise, we pretty much rebuilt it up here. All right, very cool deal. So I'm going to go ahead and close out a default.js and jump back over to default.html. I'm going to go ahead and start looking at some of the HTML markup. So first, let's replace the body that we built so far with some markup that I've copied into my clipboard there. And so this is basically going to start implementing the layout that we were describing back here when we talked about the prototype of the application, right? So the header up at the top and the photo and location sections and et cetera. And if I look at the actual markup, you can see that we are in fact using some of those HTML5 semantic markup elements, header, sections, et cetera, but we still got good old divs, images, and iframes. And in fact, if I look at the image, I see that there's a tap here .png that's supposed to be in the images folder, and I don't currently have that. So I'm going to go add that guy in. And this is part of the assets that are included with the zip file if you download it using the URL that's at the bottom of the slides. But back over here, I'll add that guy in. And then I also see this iframe. Remember we talked about the web and local contexts and all that, and that we were going to have a map.html that basically used the Bing Maps control and needed to be loaded in with that ms-apex.web URI protocol scheme there. And so that needs to be in an HTML folder, the map.html. So I have to add those guys in as well. So I'm going to right click and add a new folder, call it HTML. And then I'm going to add from my assets that map.html file. We'll talk through that coming up here shortly. All right. But otherwise, just good old normal HTML5 markup editor here. It's got IntelliSense to help me with my code completion, etc. But I don't actually currently in Visual Studio 2012 have a design experience for HTML. So that's really where Blend comes in. So I'm going to right click on default.html over here in the Solution Explorer and say Open and Blend and save up any changes. And it's going to go launch Blend for me and actually open the project up in Blend. And you'll notice that here I actually do get a visual representation of what the application would look like. And this is in fact rendering it live. As I make changes, it'll show me what it actually looks like. And I can see a simulated outline of my tablet device and all that good stuff. And so here's the basic layout. If I look at Blend here, I've got a number of panels. In fact, I'm just going to press F4 on the keyboard to toggle all the panels open so we can see them. The projects panel here, you'll notice, has the exact same project that Visual Studio is working with. So that's great. Blend and Visual Studio share the same solution and project structure and can both use TFS for source control. I've got assets panel, which is kind of like the toolbar. And so it's like from here that I could easily drag out, remember that rating control, and it would write the div element with the appropriate data-win- control attributes for me. And then I've got a couple other things here. The style rules shows me the different CSS documents that apply to the current page. And I can use this to control which one I'm editing as I use the GUI to set styles. I've got this really cool live DOM Explorer down here that shows me a tree view of the document object model. And you'll notice that as I select elements in the live DOM, it selects them for me on the artboard, as well as down here in the default.html markup. And I can also use the CSS properties panel to see or modify the CSS properties that are being applied to that element, as well as the HTML attributes that are applied to that element. So that's pretty cool. So really, if you look at that, all of these panels here, in fact, all of this stuff in Blend is really focused on, I guess, really pretty much just about everything. It's focused on helping you write your default.html and default.css in there. So that's really cool. And of course, at the end of the day, it's those files that exist, right? So the files are the truth. The rest of the stuff is just there to help you edit those. And at any time, if you want to, you can just click into there and start typing away. You don't have to use the GUI editors, but that was the whole point of Blend, was to have a design experience, right? So there's a few things I want to do in here. First of all, I want to go in and start to style this up so it looks more like our prototype application. And I want to make sure that as I do this, the changes that I make are going to be done inside default.css. And I want them to occur after the body selector, but before the media queries. And so that's what this orange bar here is going to do. I can drag that up, and that's my insert bar. And it basically says, as you go start using the GUI to create CSS, it's going to be inserted into that document at that point. So that's really cool. So I'm going to go ahead and grab the body element here, and over here on the CSS properties, I'll make sure that I'm working on the body CSS selector inside default.css, and I want to use grid layouts. Now, grids are actually in process of being becoming specification in HTML5, but because the spec is still in flux, to make sure that we had a consistent target, we've implemented our own grid mechanism. But again, with the intention that when the CSS spec becomes ratified, we'll change to just using that. So I'm going to do -ms-grid. And then for the grid, I want it to be a single cell grid, one column wide, one row high, consuming the entire screen. So I'm going to say it's one fractional unit. Think of that as like 100% for a column, and one fractional unit, one column consuming the entire fractional space, and one row consuming the entire fractional height for that cell. All right, so that's the body. Now down here on main content, I see that that's a div with an ID, and I want to create style specifically for that element. So I'm going to right click on it and say create a style rule from the element's ID. And you'll notice that in the CSS, it created this main content selector for me. Now this is also going to use a grid layout, but it's in a grid. So I'm going to tell it in its parent grid to be in column 1, row 1. Oops. Column 1, row 1. All right, but it too is going to use a grid layout. In fact, if I go back and look at our prototype, so the body was this one cell outer grid. The section for the main content panel that we're about to create actually has 3 rows. There's one for the header, another one for the body, and then another one down here at the bottom for just sort of some white space. So 128 pixels high, one fractional unit high, and then 60 pixels high down there at the bottom, but one column wide, the entire width of the display. Right, so we'll flip back over here and implement that. Say, okay, well, this is also a grid. Its columns are just one column that consumes the entire fractional space, but rows will have one that's 128 pixels, one that consumes the remainder of the fractional space minus a little 60 pixel footer down at the bottom. Right? And as I press enter, you can actually see the blue lines that represent those rows showing up for me over here on the artboard. And in fact, if I want to, I can come over here and grab them, reposition them, resize them, whatever, and you'll see that it's writing the appropriate CSS for me down below. I'm going to Control-Z to undo that. All right, so now within main content, we have a header and a section. Now notice that these are elements that don't actually have an ID, but I want to create CSS styles for them. So I'm going to use an ID form, and I could go type an ID here in the markup. I could go to the HTML attributes to do that. I really like just doing it right here on Live DOM. I can just click on it to select it, and then just type in the ID that I want it to use. Then, now that it has an ID, I can create a style rule for it. And again, returning back over to our prototype, our header row, I see has 3 columns, right? 120 pixel wide, one that's fractional unit, remaining space, and then a little 40 pixel column. So that's good. We'll go set that up. Sorry. So the header here is in its parent, going to be in column 1, row 1. But it too is going to be a grid and made up of 1 row, but 3 columns, 120 pixels wide, the remaining fractional space, and then 40 pixels wide for the last column there. Cool. Inside the header, I have an H1, and I'm going to go ahead and position this guy. I'm going to use its title area class. So I'm going to create a style rule from the existing title area. We're going to move it, right now it's in column 1, we want to move it over to column 2 in that header that we just created, and it's supposed to have a little bit of a margin up here at the top, so it's a 37 pixel margin that I want to give it there. So we'll tell it to be in its parents row 1, but parents column 2, and that moved it over, and then I'll size or slide down here to the margin and give it a 37 pixel margin up there at the top. Now it's actually there, but the photo is covering it up right now, so we'll see that actually appear in a little bit. Section, same thing here. We need to give it an ID, so I'll call it section, and create a style rule for its element ID. And this guy actually is a 1 column wide, but 120 pixels, sorry, 1 row high, but has 4 columns, or 5 columns actually. 120 pixels, one that's fractional, 1 FR, a 40 pixel, another 1 FR, and then another 40 pixel to consume the remaining space. So, and within its parent, it's in the second row down, right? So this guy in its parent is going to go in column 1, but row 2, and notice that just moved all that stuff down, and we'll have it to be a grid, and that's going to have 120 pixels, 1 fractional unit, 40 pixels, 1 fractional unit, 40 pixels, and 1 FR high. All right. And then finally start to drill down inside that. Now you'll notice I have 2 separate sections, photo section and location section, and I noticed that there's actually something common. Each of those subsections is going to have basically 1 column wide but 2 rows, a little 40 pixel row at the top for the header, and then the remaining fractional unit down at the bottom for the image, right? So I have that same structure over here. So I really want to create a class for that, right? And I don't currently have one. So I'm going to go to the first one, right click on it, and say add a new class, and I'm just going to call this subsection and create a style rule for that. And I'm going to say that this subsections are going to be grids that have 1 column wide, but 1 column wide, but 2 rows. The top one's going to be 40 pixels, and the other one's going to be 1 FR. Cool. And so I've sort of positioned that correctly, and now I'm going to tell inside there that photo section itself, by its element ID, needs to be in that outer one, column 2, right? So it's going to be in its parents, row 1, column 2. All right. And then within there, I have a group title. That's going to be this. And then, so each one of those guys has a group title. And then underneath that is some imagery or some graphical element. In one case, it's going to be a photo. In the other case, it's going to be the map. So we already have a class for the group title that was in the markup that I pasted in here. So I'm going to just right click on that and say create a style rule for the group title. And we'll just make sure that it's always in column 1, row 1 of its parent section. So those were the defaults. I didn't really have to do that, but it helps make sure that we're being explicit. The photo, though, is really that graphic. So I'm going to add, again, a new class. I'll call it graphic and create a style rule for it, and OK. And graphics are always going to go in their parents, column 1, but row 2. And notice now the photo dropped down in there. And so now we can go back to location section. We'll make sure to mark it as a subsection. And specifically on that one, create a style rule for it and make sure that it is in its parents row 1, but column 1, 2, 3, 4 over here. So parent row 1, parent column, oops, sorry, that got changed to a 3 there, parent column 4, bingo. And underneath that, we're going to take the group title. It's already set. It's already got a class. I don't need to do anything there. But map, I'm going to right click on that and say add that as a graphic. And you'll notice it's moved it down to the appropriate place. But I want my map to stretch width and height. So I'm going to go back up to that graphic style and we'll go to its sizing and make sure that it's got a 100% width and a 100% height. All right. So I know that was probably kind of tedious to watch, but you could, if you were bored, hopefully skipped ahead until we got this done. But you'll notice that now I've basically got the layout implemented that we talked about back over here in the prototype. Now I can actually test to see what that would look like were the user to go to filled view. So on the device over here, I can actually change the view from full landscape over to filled. And you'll notice that actually the exact same layout works. It just sort of reduced the column widths for me because of those fractional units. They had less space to consume. Pretty cool. If I go to snapped, though, that doesn't look good. Or if I go to portrait, also not good. So filled and full are fine, but I want to come up with some separate styles for snapped and portrait. Now, you've just seen me implement a bunch of CSS. The process would be exactly the same, but I'm going to cheat here and paste in some CSS that I've got over here in a snippet file. So let me just grab that really quick. And in the default.css, you'll notice that down here at the bottom, there's these media queries. And so there's one for full screen landscape and one for filled. And we don't need to do anything for those. We see that those two views are currently fine. But there's also two down here at the bottom for what are the CSS changes when it's in snapped or in portrait. So I'm actually going to replace those with what I've just copied. And basically, let's flip over and see if it worked. And so here's my snap view, and that looks a lot better. And here's my portrait view, and I see that looks a lot better. But what did I actually do in the markup? Well, if I go look at the CSS for the snap view, we're basically just going in and changing, column widths and rows, etc. And so for that section, rather than being a bunch of columns wide, we made it a few rows high, and that changed where photo and the map or location sections actually appeared. So it's really just redefining the shapes of the grids and the things that are positioned in the grids, and it makes it really easy to sort of redefine that layout. All right, so we've completely implemented the HTML5 and CSS at this point. So I'm going to go ahead and save up, close all my documents in Blend, close the project, and exit out of Blend. When I return back over to Visual Studio, then Studio sees that all these files have changed. So I'm going to say yes, reload everything. Make sure you say yes to all. I'll go ahead and say that, and it basically has reloaded it up. And at this point, we've completed the HTML5 CSS markup. We're ready to jump over and start looking at the JavaScript side of things. All right, so let's give this a quick run, first of all, just to see what it looks like. And I can see that it's functional. And in fact, I even have a map displaying. That really is the Bing Maps control showing inside that iframe. And it's because it's been fully implemented inside that map.html that I dragged in. We'll walk through and see what it's actually doing there in just a second. The photo just has that placeholder tap here, sort of picture saying tap to capture the photo sitting in there. But the first thing I want to do then is the location stuff. So I need to have that default.html and the default.js behind it actually go talk to the geolocation device on the Windows 8 computer and retrieve back my current position, and then feed that data over to the map page where the map page can show it as a push pin. So let's go make that happen. So back over in Studio, we'll get out of debug, and I'm going to jump into default.js. And I'm going to do my initial sort of code here inside the onActivated function. So I'll scroll down here, and I know that I'm going to need to talk to the geolocation device. So I'll go ahead and new up a variable here, and that's going to be a new windows.devices.geolocation.geolocator. So that's my geolocation device. That's how I talk to the GPS. Pretty easy. And then I can tell the geolocation device to basically get my current position asynchronously. Now, I mentioned async operations being a common thing in Windows 8. So that basically says we're going to have Windows 8 or this app go off to the Windows 8 GPS and wait until it gets the position back. Now, normally, if this were done synchronously, that would be a blocking operation, and nothing else would be allowed to continue inside my application while that happened. But with this being called asynchronously, if there's other things running right now that are updating the UI or whatever, they're not going to get blocked, and that's great. The problem with async, though, is that usually we have to deal with callbacks. And we say, okay, well, call the async method over here, but then when that's done, then there's this callback function. I'm going to have you go run that, and that's over here, etc. So we have a simpler syntax for that with Windows 8 JavaScript. And I can basically say, hey, look, if I look at this geoposition async function here, I see it returns an iasync operation with a return value of a geoposition. And so I can basically say, hey, look, go run that. And then when that operation is complete, here's the function I want you to run. Or if that operation had an error, run this function. Or if it just gave me a progress update, run this function, etc. And in fact, that complete could fire yet another promise or another async operation that I could then, and then, right? Promises, 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 right? On the other hand, it could be that what you do afterwards doesn't need yet another promise after the fact. I can just say, hey, when it's done, then run this operation for complete, run this operation for error, run this operation for progress. That's really cool. So in fact, I'm going to go ahead and say, hey, let's go ahead when it's done. In fact, we'll come down a line here. When it's done, we'll create this function that takes in. Remember, I was going to get a geoposition back. So we'll just take in the position. and that's going to be our complete operation. I could also, however, get an error back. Come on, Brett. Bingo. And in fact, I already know right now that I'm going to want to be able to display some error information. So I'm going to go ahead and new up a dialog. And we'll toss in the error.message and the title of location error. Something like that. Yep. My fingers are fighting me right now. Okay, so that's sort of my error handler. If we do get an error, we'll get a little message dialog telling us what the error message was. But otherwise, as long as the position is retrieved successfully, then I want to first of all remember it, because you might remember when I talked about the prototype, I said once we have a location and a picture, we want to be able to share them. So I need to remember my location somewhere. So I'm going to go ahead and just save this last position. I don't currently know it right now, so I'll just set it to null. And then down here, though, we do know it. So I'll set last position equals, and I'm just going to make a little JSON object here that has a latitude. And we'll go to our position. Man, me and my fingers. Position dot coordinate dot latitude. And my apologies for the typing there. We'll add in a longitude from the position.coordinate.longitude. All right, so that's my last position. Now, the other thing that I want to do is take that same position data and send it over to this map.html file. So let's go look inside there. Inside map.html, remember the whole purpose of us running it in the web context. Remember back over here on default.html, there was this iframe that said load it into the frame, or load that map.html into the frame using ms-apex.web, right? And so because this is being pulled into the web context, it has permission to go access remote scripts. And in fact, it's jumping up. I said the Bing map servers, but the actual URL is at virtualearth.net. But there's that map control resource, and that's going to be the JavaScript code that implements the map control for us. And then when the DOM is finished loading, the map initializes by coming down here and calling this init function that basically just news up a map control and overwrites this div down here, map div, with the map control. It basically says, hey, go create a map for me on that map div. Here's the API key for Bing Maps, etc. Use your own, and then loads it up as a roadmap. Pretty cool. So that's what actually made that map show. You might remember when I ran it, we saw the actual map appearing. But now we want to be able to pass in a position and have this pin location take the latitude and longitude, create a push pin, and place the push pin onto the map, right? And so we need a way of sending in that message. So we have another event handler up here at the top of map, which says, hey, listen for a message. And that's from the iframe post message API. And when that happens, we're going to process the message. Now, when you pass a message across to an iframe, you get to decide what you want the message to be. In our case, the message is going to be the name of the function we'd like to call and the arguments for that function. And specifically, we're going to tell it that the name of the function is pin location and that the arguments are this lat and lon, right? So what we do in the process message is, first of all, make sure that we got a message with data and that it's coming from the local context. As long as it is, we parse the message data out into a JSON object and then check the JSON object to make sure that it has a function name property. If it does, we create a pointer to that function name on the current page and verify that that object is in fact a function. As long as it is, we call the function passing in the arguments that we got through the message. Okay, so that's the basic idea there. Now, if I jump back over to default.js, then I need a way of basically saying, hey, let's build a message that passes along to the map frame, the pin location function name, and the latitude and longitude as the arguments. And so to simplify my life here and to keep you from having to watch me type that, I've gone ahead and built one here that I can just paste in. So I'm going to copy that code. and we'll talk about it. But basically, this guy is a function called call frame script. It needs to know the name of the frame we're going to send a message to, the name of the function we want to run inside the frame, and the arguments for that function. We take those arguments and new up a JSON object that has those properties, and then basically use the frame's post message API to send along a JSON string for the message to the web context in that frame. Pretty easy. So all I have to do up here then is say, hey, call the frame script for me. From the document frames, go get the map frame. That's going to be the target. We want to call the pin location function. And we need to send along this array of arguments, and that's going to be the position.coordinate.latitude and the position.coordinate.longitude. Cool. And there we go. And that should do it. So I should be able to now execute this and watch it fail. Notice I get this access is denied. Now remember, I did also add in an error function though, if the get location failed. So let's tell this to go ahead and continue. And there's that message dialog. So we do see that my error handler actually is working. It's just Visual Studio was going ahead and breaking when the error occurred anyhow, so I could see that. All right, but location error, access is denied, and all I have is a close button. So let's go ahead and shut the app down. And the reason I'm getting access is denied is imagine that you yourself purchase an app out of the marketplace. If that app wants to use your location, you want to be able to permit it or control that permission. So that's actually something that as an app developer we have to ask for. We have to ask for the permission. So I've opened up my package.appx manifest file. On the capabilities tab, we have to ask for the permission to use location. So I'll save that up and let's run it again. And now Windows 8 is asking the user, hey, this Here My Am app is trying to use your location. Do you want to allow it? Yes or no? And they can choose yay or nay. I'll go ahead and allow it. And boom, there's my location. You can see I live out in Ramona outside San Diego. Pretty cool. All right, so that's functioning. So let's go ahead and stop that and return back to Visual Studio. All right. So we've got location working. Now let's go take a look at what we need to do to get the photo stuff working, right? So back over here in default.js, just like we were remembering our last position, I know I'm also going to want to remember the last picture that I captured, and I'll just set that to null, right? And then down here in my on activated, we're going to want to wire up some variables. But if I look at my default.html, notice that I have an image element called photo. And it's via its source that I'm going to want to actually show the image. Okay, so I need to get a reference to this image element. So back over here, I'm going to go ahead and create a variable. I'll go get a reference to that photo element. And then I'm going to wire up on that image. I'm going to add an event listener for whenever you click on the picture. I'm going to have it go run a function that I haven't created yet called capture photo. And I'm going to bind the this object in capture photo up to that image element that we just captured. Okay, and I'll explain what I mean there. All right, so if I come down here below my call frame script that we used in the last demo, I could create a new function. Remember, I called it capture photo. And the whole point of that binding is that inside that function, whenever I say this, it's a reference to whatever it was bound to, in this case, the image element, in which case image element is the photo, right? So it's that photo element down there. So inside here, I could say, hey, var, the image element that we're working with is whatever this is in there. And then I could also come in and state that I'd like to use the Windows 8 photo capture UI. And I'm going to do that from windows.media.capture.camera capture UI over here, right? And so from there then, capture UI, oops, sorry, let's new that up. And then there's a whole bunch of things that I could do with this, like capturing a file asynchronously from the Windows camera capture UI. We can go in and set settings on it, right? Like maybe what's the format of it, like PNGs or JPEGs or whatever. Now, again, I've actually got some code implemented here, so to keep you from watching me type all of that, I'm going to go ahead and paste in some code to take care of the capture photo function for us. and we'll talk through it really quick. So we saw all of this, the var image element equals this, the var capture UI, getting the camera capture UI. I can set photo settings.format and make it return the photo back to me as a PNG. I'm going to allow you to crop the image, but I want to keep the aspect ratio, the relationship between the width and the height, to be the same as the images, the image elements width and height relationship. So it'll make it fit undistorted into that image element. And then I tell it to capture the file asynchronously as a photo as opposed to video, right? So that makes sure I get a photo back. Now that's an async operation, right? So when that async operation is done, we run a function on the captured file. And in our case, we'll make sure that the captured file exists and save it in that variable that I created up above so we can share it later on, and then simply set our image element source up to a temporary URL that gets created to the object for that captured file. That's a one-time only URL. Once we've used it, we can't use it again. And if there's any error, in this case, instead of doing a message dialog, it's just logging out to the console. All right. So again, that's it. That's all I really need to do to wire that up. So let's give it a try. I'm going to kick this off. And I'm going to come down here. Remember I said I wired up the click event handler to this capture photo element. And so when I click on it, notice it actually complains and says, the app needs permission to use your camera. Just like we have to have permissions to use the location, we also need permissions to use the webcam. So again, I'm going to shut the app down, return back over to Visual Studio. And if you remember, those permissions were often package.appxmanifest. Over on the Capabilities tab, we turned on Location earlier. I now need to ask for webcam permissions. So this is effectively going to redeploy the app for me. So it's going to ask me about location again. I'll allow that. But now when I go to tap to capture the photo, there it is. There's my permission. Do I want to allow that to happen? Allow it. And it actually goes to the camera on my laptop, and there it is. Hey, so you can see me. Woohoo! There's Brett. And in fact, I have a higher quality webcam hooked up, so I can change camera and go to my higher quality webcam there. And then I can simply tap in here to take my picture. And remember, I said to allow it to crop, but to keep the aspect ratio the same. So there we can see the aspect ratios being maintained, but I can crop it and pick the image that I want and say OK. And there I show up. Fantastic. So I've got a location, I've got a picture. I'd love to share this amazing data with the rest of the world. So I'm going to move my mouse up to the top right-hand corner and come down to the share charm. And it says this app can't share. And that's because I'm not offering up any data. So let's go implement the share charm. We'll shut this down. And again, return back over to Visual Studio. So I've got everything working except sharing. So again, I'm going to come back over here to default.js, and we'll continue to add some code here inside our onActivated function. Now, as you go to share with Windows 8, you can be either the source of sharing, where you provide data out, or you can be the target of sharing, where you consume data. In my case, I just want to provide data. Basically, what's going to happen here is when the Windows OS wants data from me, it's going to look for a data transfer manager inside my application that can provide data up to it. So I'm going to come in here and new up a data transfer manager, and that's going to be from the windows.data.datatransfer. Windows.applicationmodel.data manager. And I don't actually new one up, I get it for my current application. And that's going to be how Windows 8 knows how to talk into it for me. All right, so then I can take that data transfer manager and basically on data requested, and that's what Windows 8 is going to do when it wants my data to share. It's going to say, hey, give me your data. And so I need to basically provide data up to it. So I need to implement this provide data function down below. And again, I'm going to make this pretty simple. I'm just going to steal some code here to make that easier for us. And down here under capture photo, we'll paste provide data in. So this code basically is going to take into data transfer event request args, and from that we can get reference to the request. That's what the OS is asking for us. And the way that we either get data or provide data is through this data property on the request object. All right, so that's the payload. If we were the target of sharing, we'd consume the properties out of data. But since we're providing it, we need to set the properties. And what we're going to be sharing is our position and our photo. And if we don't have those, then we might as well just exit out. There's nothing to share. But otherwise, this data object has a bunch of things that we can set on it, right? So there's titles and descriptions and all that kind of stuff. And so that's just what this code down here is doing, is setting the title to the application name. We'll make the description be our positions, latitude and longitude. And then we'll actually go create a thumbnail from the last capture photo. So we've got a stream. We'll read that stream out and create a thumbnail from that, as well as embedding the image a couple of different ways. And you probably, with images, want to do it one of both ways. But I have this thing called storage items, which is kind of an array where you can have multiple things you want to share. Or there's a singular bitmap that you can also set on set bitmap. And so you kind of want to probably do it both ways so that you'll have the ability of sharing it with more target applications. But that's it. Again, complete and ready to go. We've said, hey, we've got a data transfer manager. When it's asked to provide data, it will. And here's the data it's going to provide, and that's the title and description and picture. So let's run it. I'm going to go grab a photo here. We'll just really quick grab one. Oh, beautiful. Out of focus. That's okay. And why isn't my location sharing up here with me? Yeah, for some reason my map didn't update there, not sure why. But okay, I've got it. Here I am at my Latin lawn. And notice that here's all the different kinds of apps that I can share my data with. It remembers that I like to email myself, though, so that's up there at the top. I'll go ahead and click on that, and pulls my photo in. I can toss a subject in, fuzzy photo, add a message in, woohoo, and send it off. And it's now emailing my photo off to myself. All right. So I'm going to go ahead and shut the app down and close out over here in Visual Studio, and we'll save that up. So at this point, hopefully you've seen sort of an overview of how it is that we can go about creating HTML5, CSS3, and JavaScript applications that run in Windows 8 using Visual Studio. And hopefully you saw that most of what I was doing in there, at least in terms of syntax, was just the same old HTML5, CSS3, and JS that you're used to. But taking that to leverage that Windows Runtime and doing things like talking to the geolocation device or calling out to the camera capture UI or implementing to Windows 8 specific things like sharing. So in that last demo, I was creating an application from scratch using Visual Studio and writing the HTML5, CSS, and JS myself or using the design tools. Right? A popular thing to do, of course, on these various consumer mobile devices is to create games. And there's actually a lot of ways that as an HTML5 developer, you can create games for Windows 8. So we'll talk a little bit about HTML5 games and gaming engines here. So really, you have the choice of how much detail you want to have to go into as you create games. HTML5 has a very powerful canvas element that you can use to create great two-dimensional games out there. And you could just sort of write your own code and just directly start implementing things inside the canvas. There's a lot of great information on doing just that. And if you grab the slides, there's a link off to the documentation for the canvas element for Windows 8 there. To make life a little bit easier, though, for you, and as you get in and start creating games, you have to implement a game loop. You need to have ways to load assets into the games, to do things like collision detection and things like that. So there's a number of mid-level gaming APIs that are out there. Impact.js and Create.js are examples of those. There's physics engines like Box2D, etc. And those are still code solutions, but they keep you from having to implement the low-level logic that those frameworks and APIs give you. And then you could start to step up and say, well, what if I wanted to create a game and not necessarily have to write any code myself? And so there's a variety of game creation studios out there. One of the ones I've been playing a lot with lately is Construct 2 from Skira. There's Yo-Yo, Game Salad, etc., and some other ones out there as well. And the idea here is that these are really what I call code as an option solutions here. And some of them, you're closer to the code than others, etc. But for example, with Skira Construct 2, I say that for the most part, if you can write an Excel formula, you could probably build a game. And you can extend it further if you want to write code. You can create what are called behaviors and plugins, etc., for Construct 2, and the other frameworks have similar ideas behind them as well. So with Construct 2 as an example, I've got this Construct 2, game creation utility. I can drag my graphical assets in, associate behaviors and properties with them, and then to wire up their behaviors, I have events, and events are basically a way for me to point and click and sort of build up, the logic of my game. And then be able to actually export that game out to a variety of different formats, but of course, including Windows 8 and Windows Phone 8. So let's go take a look quickly at an example of a game in Construct 2. All right, so I've got a folder here with an existing Skira Construct 2 game. This is actually the Go Shooter game that you'll build if you go through the tutorial up on Skira's website. And I strongly recommend you do that. Even if you're not going to use Skira long term, I think it gives you a great idea of just exactly what these gaming frameworks can do for you. So I'm going to just go ahead and double click on this to launch Skira's Construct 2 tool for me. And you'll notice that it pulls up and I can sort of see my game layout right here in front of me. And so I've got a project that's made up of one or more layouts and event sheets, as well as a bunch of object types. And within any given layout, and think of a layout as maybe the different screens of your game, etc. You can have multiple layers. And so there's this UI layer where there's the score and a game over, press space to restart. And I'm just kind of turning that off right now so I don't see it here in the design view. But along with that, then I've got a background. If I, unblock that or unlock it, I can grab the background, and I see that's a tiled background there. In fact, I can right click on that to go see the image that's in it, and I see it's just this sort of bricky looking ground that's being tiled to fill up this 1280 by 1024 layout size there. Then I've got my player, and my player is what we call a sprite. I can see its size and its position, but these various objects that we've dropped onto here have what are called behaviors associated with them. So in fact, I can see that this guy has a few different behaviors, an 8 direction, bound to layout, and scroll to. And I could change those if I just were to, with this guy selected, come over here and say add edit behaviors. And there's the 3 that it has, but I could go in and add additional ones. So notice we have things for like platformer games, solids and jump throughs, drag and drop, flashing things, a bunch of different behaviors for different things here. So I'm going to cancel out of that. I don't want to actually change any of these. And then I've got the monsters. Now the monsters are actually my enemies, right? So they're going to be moving toward my player and trying to catch him. My player is going to be able to shoot bullets, and there's a little bullet up here, up off the top of the layout there. And it's off, oh, sorry, I don't want to move that. Let me lock my background again. But we'll scroll up here so we can see it, right? So there's a little bullet, and in fact, there's an explosion as well in there. And so you sort of lay things out just visually, right? Like I can click on a monster and move them around to set their initial position, etc. So the way I actually implement the game logic is on these event sheets, right? And so you have the ability to come in and define an event. And an event can be related to the system itself or to one of the specific objects that you have, or maybe responding to keyboard or mouse or touch even, etc. in there. And then within an event, let's say I was going to add a system event, you could say, well, maybe every tick, every loop through the game, I want you to do this, or when the game is started or when the game ends, whatever. There's different conditions that you can set up. And then within an event, you have what are called actions. So here's all the ones that are in Go Shooter. We see it on system on start of layout, turn the monsters randomly 360 degrees, and hide the text that shows to press space for the game to start. We have every tick or every time through the loop, we move the player or we set the player's angle towards the mouse. And if I go in and look at any one of these, you'll notice that the expressions aren't really even code. They're just very simple sort of statements. So you really don't have to write much code there. Now, I'm not going to walk through this whole thing, but basically, once I've implemented this, we've got things that says, hey, look, when you click the button, spawn a bullet from the player at layer 1 at image point 1. Let me jump back over here, and we'll zoom in and look at our player here and turn off that overhead. So here's the player, and if I actually right-click on that and edit its animations, I can go to its image points, and I see there's two of them. There's the origin, and that's actually hard to see here, but there's actually a little crosshair right there in the middle of the player. And if I go to this one, it's image point 1, and it's this little dot that's sitting out there. And notice it's right at the tip of the gun that the player's holding. And here I'm looking down on top of the player. So he's standing with his hands out in front of him holding a gun. And he's got some funky sort of jetpacky looking thing on his back. All right. So if I go back and look at that event, it said when I click on the button, spawn a bullet. So create a new bullet at image point 1. So it'll look like the bullet's coming out of the tip of the gun. And we're going to set, or sorry, down here, if the bullet collides with a monster, so there's my collision detection, then go ahead and spawn an explosion and subtract 1 from the health of the monster and destroy the bullet and make the monster even go faster. So a whole bunch of cool things here. Notice I'm not having to write code to implement that. That's the key. Finally, down here, if the monster collides with the player, then we destroy the player. So that's how you lose, is that you get caught by a monster. All right, so I can go through and wire these guys up, and when I'm ready, I can run this, and by default, it's going to run as an HTML5 game inside the browser. And there it is. Notice as I move the mouse, the player moves towards it. I have the 8 direction behavior, means that I can hit the up, down, and left, right keys on the keyboard to move my player around. And as I click to shoot, notice it takes multiple shots, but we see the bullets spawning. When I collide, whoa, I'm going to die here. And once they finally catch me, game over. Right? And so you saw all the logic there on that event sheet. Of course, you'll want to take some time to read through it. But it's that easy sort of to make an HTML5 game without actually having to write any code. Really cool. So here's the other really cool thing. If I go to the home ribbon, notice that I can actually export this game. And it supports exporting to a variety of different formats. But of course, from a Microsoft perspective, we love that you can export directly to a Windows 8 or even a Windows Phone 8 game. So I'm going to do Windows 8 here and go on to Next. And it's actually going to create for me a Visual Studio solution. So I'm going to go out and browse out to my folder here for my demos. And we'll call it, how about GS for Ghost Shooter W8. All right, and a subfolder for images and media, etc. You can have it minify the script. I'm not going to worry about that. I'm going to go and export it. And open the destination folder, and you'll see that what I actually created for me was a Visual Studio solution. So I'm going to double click on that, open it up in Visual Studio. And you'll see that it is, in fact, just an HTML5 JavaScript app, just like we were talking about building in the beginning of the video, although now it's all been written for me using this Construct2 gaming engine. Really cool. There's one thing I need to do inside the package.appx manifest. I need to give it a certificate. Construct2 doesn't generate the certificate. So I'm just going to make a test one here so we can debug it and run it. But this is now a Windows 8 game, right? If I go back and look at running it from Construct2, you see that it's actually in the browser, right? This is a browser-based HTML5 game. But now that I've pulled it up inside Visual Studio and I run it from there, it is really a Windows 8 game. And so I could basically just spend a little bit of work and publish this up into the Windows Store here. We'll let myself eventually die. And there it is. We'll go ahead and shut this down. All right. Very cool. Great. Well, hopefully this has been a good overview for you. We started out with an introduction to Windows 8 architecture. We also looked at HTML5, CSS, and JavaScript apps in Windows 8, and wrapped up looking at HTML5 games and some of the different gaming engines and frameworks that are available for you. Tons of great resources out there. I did mention that the sample app that I was going through was from the free ebook by Craig Brockschmidt, Programming Windows 8 Apps with HTML, CSS, and JavaScript. So you might want to go grab a free copy of that. Tons of resources for developers at dev.windows.com, including a free version of Visual Studio Express for Windows 8 and links off to eval copies of Windows 8. Design resources at design.windows.com. And of course, you can always follow up with me, my blog, brettstatham.com, or find me on Twitter or via email. The link for the slides and demos is down there at the bottom of the screen. And thank you very much for your time.